This is my 30-pound combat robot, the Hash Slinging Slasher. It's one of the most complex combat robot builds I've ever done, using a nifty combination lifter and devastating articulated circular saw. In this video, I'll show you how I designed and built it and how it fared against Australia's best combat robots. This video was made possible by PCBWay. More on that later. So, what are combat robots anyway? Well, you can think of these machines as specially designed remote-controlled vehicles which compete against one another to the death in a purpose-built arena. Just like boxing, combat robots compete in weight classes, from the tiny 150-gram ant weight class all the way up to the heavyweight monsters you see on TV, which can weigh all the way up to 250 pounds or 113 kilos. This combat robot is built for the Sportsman Featherweight division and weighs 13.6 kilos. And trust me, at this size, it is more than capable of causing serious damage. The first stage of any design is figuring out what you want to make. And for this competition, I wanted something I'd never made before. I've built wedges and high energy kinetic energy spinners before, but the Sportsman division is unique in that it doesn't allow either of those designs. You must have an active weapon of some kind, but it can't be your typical tombstone style spinner. This allows for a much wider range of weapons to become actually viable, such as lifters or hammers. Saw blades, however, are allowed, and I've always thought one on top of an arm that you could drop into the thin top armor of bots would be really neat. But no one is going to just sit still while you saw into their bot, so I also wanted a lifter of some kind, and this is the mechanism I came up with. This linkage allows me to control both the saw arm and lifter using the same gearbox. The saw arm is rigidly fixed to the shaft, while the lifting arm is free floating and rotates in place on these two metal plates. In normal operation, it just rides on the floor, but once the saw arm goes back far enough, this cam here engages with a bolt between these two plates, and this pushes the lifting arm up. I played with this mechanism for ages, figuring out the best angles, where I wanted the arm to engage, and how it would attach to the shaft. I'm really happy with it, but how do you go about making something like this? I don't really think 3D printed plastic would hold up, but how about CNC aluminium? Well, that's where this video's sponsor, PCBWay, comes in. You may be familiar with PCBWay for their PCB prototyping and production service, but did you know they also offer 3D printing, laser cutting, and CNC machining? Oh yes. To use PCBWay's CNC service, all you need to do is save off your parts individually as like a step file, and then you upload it to their service. From there, you can select what material you want as well as the surface finish. I just went with as milled 6061 aluminium, but you can get tumbled or even anodized in a range of colors, which is super cool. It'll give you a live quote as you go, but what's neat is PCBWay will get an actual technician to go over your parts to ensure that they can be made using the CNC process. Stuff like minimum radii and tool accessibility. In addition to the CNC metal parts, I also uploaded DXF files for the lifter arm plates to be laser cut from 4mm steel, as well as some 3D printing components for an upcoming video, which were done using HP's MJF process in nylon. They look stunning, and I cannot wait to show you what they're for, so better subscribe so you don't miss out. Once the technician has approved your parts as suitable to be manufactured, you can go ahead and complete the order, and then shortly after, these parts look awesome, especially considering I didn't request any additional finishing processes. To take full advantage of the CNC machining process, I also pocketed some of the parts, and they really do look cool. Pocketing is the process of removing material in strategic areas to reduce weight without affecting part strength, and there's no way I'd be able to do this kind of thing by hand. So that's the parts, but what gear motor is powerful enough to lift over 13 kilograms of combat robot without breaking? How about this 3,000-pound car winch? Car winches are designed to withstand incredible abuse, so they combine a powerful 12-volt motor with a hugely durable planetary gearbox. My plan was to use the stock motor and gearbox, but swap out the front plate with my custom CNC'd one from PCBWay and it worked perfectly. The thing is though, I kind of knew it would because I prototyped the entire mechanism in PLA plastic before committing the parts to metal. Once again, even a humble budget i3 is an incredible prototyping tool to have on hand for builds like this. The only thing I would change for next time with these parts is my clearances. I'm so used to 3D prints being inaccurate, they added a slight amount of clearance to the bearing holes. Professional CNC, however, is a far more accurate process, and this resulted in a loose fit instead of a firm press fit. Loctite kept them in place in the end, but next time I'll definitely tighten down my clearances. I did a test assembly and all was looking great, but then that one problem I had that I was ignoring came back to bite me. Just how do you attach a 20mm shaft to the output of a gearbox with a non-standard splined shaft? I thought, oh, I'll just like lathe it down and weld it in place or something, but A, I don't have a lathe, at least anymore, and B, welding a shaft to be perfectly concentric is well beyond my capabilities. The solution? I put a spline on the shaft myself, by hand, with an angle grinder. Yeah. It sounds absolutely absurd, but I traced the spline groove locations onto the shaft and then went to town grinding as straight and as accurate as possible, repeatedly testing and marking where more material had to be removed. And it absolutely worked. A complete hand-ground spline which engages into place with just enough play so it can ride in rigid mounted bearings, but the spline has enough engagement to transfer gobs of torque to the lifting mechanism. Probably one of my proudest achievements, but it's all completely hidden away, but at least you guys know how much suffering was involved getting this thing to work. With the weapon mechanism working, at least in theory, it was time to build the rest of the robot around it, and for that, I headed down to the scrap metal yard. Metal is expensive and hard to get in small quantities, so if you're lucky enough to live near a scrap metal yard, I highly recommend visiting them. This place is awesome and has piles of steel lengths and all sorts of crazy things, but I was mostly interested in the aluminium sheet and lengths. I grabbed what I felt would make a good bot, including a 3mm sheet for the base plate, and then shoved it all into my poor little Echo. Because Sportsmans aren't overly destructive, I opted for this super thick chopping board for the back and side panels. It's made from HDPE, which is incredibly durable and easy to work with, and a lot easier to get as chopping boards than just the plastic sheets itself, as well as usually being cheaper. Go figure. While I initially intended to use my ancient jigsaw, it's seen better days, so I finally decided to get myself some real tools, including a new workbench and this super snazzy bandsaw. Okay, it's just a budget one, but let me tell you, for building stuff like this, bandsaws are awesome. I highly recommend picking one up if you intend to work with soft metals and plastics with any kind of precision and speed. Just don't feed your fingers into the blade and you're sweet. And well, from here, it was just a simple matter of measure, cut, drill, tap, repeat, again and again and again. I measured some things, but really, a lot of the assembly was done by simply lining parts up so the holes had no choice but to also line up. There's something to be said for this kind of assembly compared to trying to be precise with measurements and CNC processes. Each approach definitely has its place, but you really don't want to be crazy precise when putting together a combat robot, because when it's thrown around the arena for 3 minutes, you can guarantee that those precise holes won't be as precise as they started out. So I always put as much generous clearance as I can into my holes and assembly when putting these things together. For drives, I went with the same brushless gear motors that I stole out of Vanguard, a robot I built about 5 years ago now for the unrestricted featherweight class. They're from Banebots with a Hobby King Outrunner, and I was initially going to use the same huge 3D printed gears from that robot, but I never really fully trusted their durability, so with the help of a friend, I got these hubs made up to hold the wheels securely in place. And the saw motor is the same crazy powerful 5045 brushless motor that I used in the world's most powerful PC fan with a 2-to-1 reduction to the output. It's a bit defenseless out in the open like that, but for a version 1, it'll have to do. The actual weapon shaft is a shoulder bolt, which have this precision ground surface that rides on bearings with a special angle grinder washer that I found at the tip holding the disc in place. And about these saw blades, there's a reason they look so old, because they are. Old school saw blades used to be thicker hardened steel, whereas modern saw blades use tungsten carbide teeth bonded to a much thinner blade. Tungsten is a lot harder and modern saw blades cut more efficiently, but those carbide teeth have a tendency of ripping off as soon as the blade encounters something hard, like a bolt or metal chassis. So for robot combat, these older steel blades are actually really desirable. They're really tough and they still do a lot of damage. You do have to be lucky to find them though. Try your local tip or maybe a flea market and don't pay much. Yes, they may be antique saw blades, but I got my pile of them for $5 and I wouldn't have paid too much more. And that's the assembly. I'd say it went together perfectly with no issues, but that would be a complete lie. I had to hand file in clearances to the weapon arm because it was jamming in on the lifter, and I probably disassembled and reassembled the front and side panels like 20 times while I was figuring out how everything went together. But in the end, it actually turned out pretty good, and it's a tough boy, albeit a little bit boxy.
Hash Slinging Slasher!
The next day, I jumped on an early bird flight after 2 hours of sleep, and after a little bit of hotel speed controller programming, it was good to go for its first fight against Beast, built by Chris of Team ARC. It's a blue fur covered robot with a monster-sized saw blade that's right up against the limit on what's allowed in the sportsman class. Here's how that fight went.
Go!
Like I said, this is the most complex combat robot I've ever built, and that means it's crazy difficult to control. You have to drive it, but also operate the lifter / saw arm at just the right time, while also making sure the saw blade is up to speed when you want it and not when it's driven into the steel sides of the arena. This fight was the first time I'd ever driven this robot with all systems online, and man does it show. Beast got some really good licks in with the saw, but I did manage some lifts, with one jamming up into the frame and requiring an unstick. I was actually pretty hesitant to use the saw because I didn't fancy it getting jammed full of blue fluff, but in the end, that didn't really matter because Beast smoked up and was forced to tap out. I believe he was running new drive motors that weren't running very smoothly, and that resulted in the magic smoke escaping from the robot's electronics. So Hash Slinging Slasher wins, but I didn't come away unscathed. For some unknown reason, the lifting mechanism stopped working right after this point, and it turns out that the fancy current limited VESC I was using just decided to call it quits. For those wondering, VESC is an open source speed controller architecture mostly intended to run BLDC motors, but you can also use it to control DC motors like this big winch with current limiting, which I intended to use to prevent it from blowing up itself and the battery and the rest of the robot. But for some reason, it died, and there's no damage to the controller, and it still responds to telemetry, so who knows? In the end, I just chucked in an 85 amp BotBits speed controller that has no current limiting that everyone said would blow up instantly, and went to my next fight against Redback. Redback is a walker, and that means because it uses legs to move instead of wheels, it's entitled to a 200% weight bonus, meaning it can weigh a full 60 pounds or about 27 kilos. Even with that much weight to play with, Joel, the guy who was crazy enough to make it, had to massively reduce the chassis weight to allow for a full pneumatic system, including an onboard 4-cylinder compressor and custom control circuitry. It's a work of art, and I have a robot with a saw blade designed to destroy things. So going into the fight, I decided to play around a bit for the first half, driving around Redback and letting it do its thing. Then all bets were off. In the end, I didn't do too much damage. I did get an airline and the balloon at the back, and I got a little bit of a leg and caused a little bit of frame damage. But I also did accidentally trash one of the air cylinders that he gave me as a souvenir. Yeah, sorry Joel. Next up, Bitzer. This was hilarious. Bitzer is built by James, who is an absolute master at design. He makes complex designs with 3D printing and CNC machining. This robot is none of those things. He threw it together with bits and pieces of plastic and junk at the event, and once people got wind that it was fighting me, things got a bit out of hand. Everyone, and I mean everyone, started donating bits of robots, armor, even complete ant-weight frames to bolt, tape, and glue to Bitzer to create this absolute abomination of a robot. And then we took it into combat. And it was one of the funniest things I've ever seen. And you would think, for a robot built from literal junk, that this fight would be a sure win. But no, because James is an excellent driver and the arena has a pit, meaning that losing is a very real possibility. And I won't lie, he had me in the first half. He was outmaneuvering my sluggish bot, getting around, and even got some hits with this piece of chopping board with a nail on the end. But that's where the fun and games ended, because I got him pinned. Enjoy.
That wheel looks juicy.
I actually did want to keep the fight going, but his robot ended up getting hung up on its own bits. And unfortunately, the only real valuable part on the robot, the impact driver, was the part that took the brunt of the saw blade. But it was such a fun fight, and the crowd loved it. So it's real proof that you don't need a good robot to have fun. And that was good enough to get the Hash Slinging Slasher into the semi-finals. And the fight for the finals was against Polaris. So you might notice that there's some parts on this robot that are a little bit more professional than my capabilities. The custom CNC parts from PCBWay are one, but these welds and these custom wheel hubs, I needed serious help from my friend Glenn, who is the builder of Polaris. So it's only fitting that my reign of terror would end at the hands of his robot. Polaris is a CO2 powered flipper. It uses compressed CO2 gas to fire a huge pneumatic ram at stupidly high speed and power to send robots flying into the air. Yeah, you can see where this is going. You might want to be sitting down for this one.
3, 2, 1, fight!
Surprisingly, the robot and my camera actually survived the first flip, albeit with a bent saw arm, and the fight went on for some time before I managed to impale his robot and get stuck in the process. But fight as hard as I did, the pit was calling my name, and Polaris was the winner. Glenn is one of the best robot builders in the country and has even competed on BattleBots, so it's no surprise that Polaris would actually go on to win the entire event. So with that in mind, I didn't feel too bad about the loss, and I did get to spear one of his fancy wheels. But that's not the end of it, because I had to get ready for one more fight to decide third and fourth place against Whacker. Whacker was built by Richard of Team Chunkalator and is driven by his kids, and they are relentless. It might seem like a bit of a silly weapon, but let me tell you, the intimidation of being constantly pummeled by a huge plastic cricket bat is no joke, and it's got heaps of pushing power from its four-wheel drive setup. Still, I did get one lucky lift in, and third place for a brand new combat robot. I'm really happy with that. For the most part, the Hash Slinging Slasher worked great, but I did get pretty lucky with the draw, I have to admit. If I'd versed Polaris first fight, then things might have panned out a bit differently. So here's what I think worked well and what I would change for next time. These little forks were almost an afterthought, but proved to be completely necessary when you consider the mechanics of lifting another robot. Let me explain. This robot can only weigh up to 30 pounds, and its opponents are the same. So if this arm gets under them and they try to lift, that's 30 pounds of weight at the end of that arm, which simply tips the robot forward. But these forks have a little profile ground into the back that only allows them to pivot up just a little bit, allowing the bot to stay planted on the ground instead as I lift them up. In the robot rumble at the end, where we throw all the robots in at once, they actually fell off and I lost all the ability to lift. So that's pretty interesting. Jumping board for the armor works okay, but it's heavier than I expected, and this huge gash from Beast in the rumble is almost all the way through. So I think I need to use a thin layer of stainless or spring steel to stop that from happening. I have no idea why the Vesk died running the winch, but these motors are notorious for killing speed controllers, and they weigh a ton. So I think for next time, I'll modify the gearbox to use a smaller brushless motor, like the one used on the weapon here, and then run the Vesk in current limiting mode so it can't ever blow up while lifting people. I don't have to worry too much about killing more speed controllers if I accidentally push it too far into its limits. The 85 amp speed controller did work, but if I kept pushing it into the robot's frame, there's no current limiting, it would have exploded very, very quickly. So continuing the got lucky theme, the weapon motor is also just completely exposed. And that's because I had to use the belts I had on hand, but next time I'm going to make it as protected as possible, because if I come across another overhead saw robot or axe or something, it'll be a really cool fight, but I don't want it to end really quickly because they take out my weapon motor. The PCB Way parts worked awesome because they allowed me to build the bulk of my machine using basic tools, but I could use 3D design to engineer a complex lifting mechanism. During the Polaris fight, the arm did bend, but that's absolutely on me. I designed a part with 6mm thickness with 2 bolt holes, and of course that was the weak point of the arm when the whole robot is being thrown onto it, and it did bend slightly. I used 6061 aluminium that I specified for the CNC parts, but PCB Way also do offer some stronger aluminium grades like 7075, which might be a better choice moving forwards for parts that I want to be really, really durable. There's also a lot more damage that I'm just sort of discovering after the rumble, because if you've never seen a combat robot rumble, it's a 5-minute fight to the death where we throw every robot left working into the arena. And you can watch it here. And a big thanks to PCB Way for sponsoring this video on Maker's Muse and providing the much needed parts for this robot. It literally couldn't have existed without them. So check out their prototyping services in the link in the video description. There's also heaps more resources down there to help you learn how to make your own combat robot if you're interested, which I fully support doing. If you're wondering why my voice is so hoarse, it's because, well, I got sick. I flew on a plane and that's just how it is. But either way, thanks for watching guys. Hope you enjoyed this video here on Maker's Muse, and I'll see you again very shortly. Catch you later guys. Bye.